Hello everyone, welcome to my channel Regular Learning Academy. I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about properties of state transition matrix, state space analysis. This is control systems, and lecture series on state space analysis, lecture number 31. So our new topics, properties of state transition matrix. Overview. Solution of state equations. What is homogeneous state equation? What is non-homogeneous state equation? What is zero state response? What is zero input response? Solution of homogeneous state equation using Laplace transform method. Basic idea of resolvent matrix. What is state transition matrix and properties of state transition matrix. So solution of state equation. First discuss about solution of state equation. Consider the state variable model of a system given in equation 1 and 2. The dynamics of linear time invariant system written in vector matrix differential equations. So what is the state equation? Our state equation x dot equals to ax plus bu. This is also called vector matrix differential equation, and this is also called state equation. Why state equation? Because left hand side only differentiation terms and right hand side free of differentiation terms. This type of equation is called state equations. And what is the output equation? Output equation y equals to cx plus du. And another form of the state equation is x dot t equals to xt plus bu of t. And y of t equals to cxt plus du of t. So this is our vector matrix differential equation or vector matrix equation, where A is a constant system matrix of order n cross n. That means A dimension n cross n. And B is the input coupling matrix of order n cross r. That means B dimension n cross r. U is a r cross 1 input matrix, and x dot t equals to axt plus bu of t, or x dot equals to x plus bu is called the state equations. Again, y of t equals to cxt plus du of t, where y is the m cross 1 output vector and c is m cross n system matrix, d is a m cross r transmission matrix, and yt equals to cx of t, du of t is called the output equations. Solution of the homogeneous state equation. If A is a constant matrix, A is a constant matrix. What is the condition? If A is a constant matrix, this is the constant matrix. A is a constant matrix and input are 0. U of t equals to 0. U of t equals to 0. Then equation 1 takes the form. What is the equation form? When ut is 0 and A is a constant matrix, then equation 1 takes the form x dot t equals to xt, because u of t equals to 0. This is equation number 3. Such an equation is called homogeneous equation. That means when u of t equals to 0 and A is a constant matrix, but x of 0 not equals to 0, then equation is called homogeneous state equation or homogeneous equation. The natural equation is if input is 0. That means in this case input is 0, how output can exist? This is also one question. How output can exist in such system? The driving force is provided by the initial condition of the system to provide the output. For example, discharging of capacitor in RC circuit. So this sentence is the very important. The driving force is provided by the initial condition of the system to produce the output. And example, RC circuit. Example, discharging of the RC circuit. So what is homogeneous state equation? Then what is non-homogeneous state equation? If A is a constant matrix and input are non-zero, then equation 1 takes the form x dot t equals to xt plus b u of t and u of t not equals to 0. Such an equation is called non-homogeneous equation. The natural equation is input is 0, not 0. In this case, input is not 0. In such system, the driving force is provided by the input side of the system. Inputs, this type of equation is called non-homogeneous state equation. And what is zero input response? Where in only initial conditions are considered and input function equals to 0. That means u of t equals to 0, but x0 only consider. X0 not equals to 0. That means x0 not equals to 0. Input function u of t equals to 0. And what is zero state response? Where in only input function is considered and initial conditions is 0. That means x of 0 equals to 0, u of t not equals to 0. In this case, u of t not equals to 0, but x of 0 equals to 0, and this type of response is called zero state response. Solution of the homogeneous state equation using Laplace transform method. If input function is not taken into account, then equation 1 is a homogeneous equation already discussed, and the solution of homogeneous state equation given the zero input response and x dot t equals to xt plus dut, and when ut equals to 0, then x dot t equals to only x a into x of t. This is equation number 3. Taking Laplace transform of equation 3, then we get for first order, this is the differential equation. For this differential equation, what is the Laplace transformation? This is s into xs minus x of 0. S into xs minus x of 0 and a into xs. This is the a function and this is the xt function. Convert xs and common xs, then si minus a whole inverse xs equals to x of 0. And what is xs? Xs equals to si minus a whole inverse x of 0. Where si minus a whole inverse, this term is called resolvent matrix, and this is also called phi of s. This is also called phi of s. So phi of s equals to si minus a whole inverse, and xs equals to what? Then put here just phi of s into x of 0. Where phi of s equals to si minus a whole inverse, phi s is called the resolvent matrix. Now phi s equals to si minus a whole inverse and common 1 by s, then we get I minus a by s whole inverse. This is the binomial form. What is the expansion? 1 by s, I plus a by s plus s square by s square plus a cube by s cube plus a to the power n by s to the power n, and multiplying by 1 by s, then we get I by s plus a by s square plus s square by s cube plus a3 by s to the power 4 plus dot 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 dot, where phi s equals to this is the equation number 4. Taking inverse Laplace transform of equation 4, then we get in this case phi s equivalent to phi of t, and taking inverse Laplace transform, this is the step function, this is the ramp function. So what is the inverse Laplace transform? Then phi t equals to what? Phi t equals to I. This is the I or 1 plus a into t. This is step function, and for this case this is I, and for this case this is a into t, because 1 by s square equals to step function 1 by t, and this is the 1 by t cube t square by factorial 2. So this is the phi of t, and phi of t equals to e to the power at, because e to the power at equals to I plus a to the power at. This is also phi of t equals to e to the power at. E to the power at equals to what is the expansion formula, exponential formula? I plus at plus a square t square by factorial 2 plus a cube t cube by factorial 3. So phi of s inverse Laplace phi of t and phi of t equivalent to e to the power at, and phi of t equals to e to the power at equals to L inverse si or minus a whole inverse or L inverse phi of s is called the state transition matrix. State transition matrix. Let the state transition matrix be denoted by phi t already discussed, phi t equals to e to the power at L inverse si minus a. Some useful properties of the state transition matrix are listed below. What is the properties? Properties number 1. Phi t is non-singular for all finite value of time. Phi t is non-singular, all finite value of time. All finite value of time. And what is the second case? Second case equals to phi of t equals to e to the power at. Put t equals to 0. Just put here t equals to 0. T equals to 0. T equals to 0. Then we get phi 0. Phi 0 equals to what? E to the power a into 0. E to the power a into 0 means I identity matrix. This is the identity matrix. Phi of 0 equals to identity matrix. Then third property is phi of t whole to the power k equivalent to e to the power at whole to the power k or equivalent to e to the power akt. This is the properties number 3. And what is the properties number 4? Phi inverse t e to the power at whole inverse, and this is equivalent to e to the power minus at, and this is equivalent to phi of minus t. Phi of minus t equals to, that means e to the power minus at equals to e to the power at whole inverse equals to phi inverse at, phi inverse t. And this is also very important properties. Phi of t1 plus t2. What is the formula? Phi 1 t1 plus t2 equivalent to e to the power a t1 plus t2, and this is the exponential form, and this is equivalent to e to the power a t1 into e to the power a t2. This is equivalent to also phi of t1, because phi of t1 equals to e to the power a t1, and phi of t2 equivalent to e to the power a t2, e to the power a t2. This is equivalent to also phi of t2 into phi of t1. This is equivalent to also phi of t2 minus into phi of t1. And another property is phi dot t equals to ddt of e to the power at. So differentiate a into e to the power at or a into phi of t. That means phi dot t equals to a into phi t. And phi of t1 minus t2, phi of t2 minus t0 equals to, just put phi of t1 minus t2 e to the power a t1 minus t2. Put here e to the power a. This is the phi of t1 minus t2, phi of t1 minus t2, and phi of t1 minus t2 equivalent to e to the power a t1 minus t2, e to the power a t1 minus t2. Then we get second term e to the power a t2 minus t0, t2 minus t0 equivalent to what? Just addition, and we get e to the power a t1 minus t2, first term t1 minus t2 plus t2 minus t0, then we get e to the power a t1 minus t0 equals to phi of t1 minus t0. And another property is phi of t equals to phi nt equals to phi nt to the power t, and phi of t equals to e to the power at, e to the power at whole to the power minus 1. So phi of minus t whole to the power minus. This is another formula. And phi a into phi t equals to what? A into phi t equals to a into e to the power at, I to the power expansion formula I plus at plus a square t square by factorial 2 plus a cube t cube by factorial 3, then multiplying by a, and we get a plus a square t plus a cube t square by factorial 2 plus a to the power 4 is cube by factorial 3 plus dot dot dot. Properties of the state transition matrix. So a into phi t equals to a into e to the power at, a into I plus at plus a square t square by factorial 2 plus a cube t cube by factorial 3, or this is equivalent to a plus a square t plus a cube t square by factorial 2 a to the power 4 t 3 by t cube a factorial 3 dot dot dot. So this is equivalent to what? This is equal to e to the power at into a, and this is also phi t into a. So 0 to t, 0 to t11 number properties, 0 to t phi of t dt equals to 0 to t e to the power at into dt. A inverse e to the power at minus I. Just simplify A inverse phi t minus I, or phi t minus I whole inverse whole into a to the power minus 1. This is another properties. And xt equals to, if xt equals to phi t into x0, putting t equals to n of t nt, putting t equals to n into t, then equals to here 1 2 3 dot dot dot, then we get x of nt equals to phi nt into x of 0 equals to e to the power a nt x0, equivalent to e to the power at whole to the power n into x0, equivalent to phi of t whole to the power n x of 0. So e to the power a plus b whole into t equals to what? Just split e to the power at into e to the power bt. If ab equals to ba, then the commutative e to the power a plus b whole into t not equals to e to the power at e to the power bt if ab not equals to ba. To prove this, note that e to the power a plus b whole into t equals to what? I plus a plus b whole into t, just exponential formula, a plus b whole square by factorial 2 into t square, a plus b whole cube by factorial 3 into t cube, a plus b whole to the power 4 factorial 4 into t to the power 4. So e to the power at into e to the power bt equals to what? E to the power at means exponential formula. This is the exponential formula, e to the power at equals to I plus at plus a square t square by factorial 2 plus a cube t cube by factorial 3, and e to the power bt equals to I plus bt plus b square t square by factorial 2 plus a b cube t cube by factorial 3. This is the expansion of e to the power at and e to the power bt. Then we get e to the power a plus b whole t minus e to the power at into e to the power bt not equals to 0. So the difference between e to the power a plus b whole into t and e to the power at into bt, what is the difference? Vanishes if a and b commute. And the methods for evaluation of the state transition matrix can be broadly classified into two groups as, what is the two groups? Methods which requires the knowledge of eigenvalues. Under this category, the methods are Laplace inverse transform method, Cayley-Hamilton technique, and Sylvester's theorem. Methods which do not require the knowledge of eigenvalues. Under this category, the methods are infinite power series method and Taylor series expansion technique. Solution of homogeneous state equation using Laplace transform. The solution of uniform unforced system. This is the unforced system. That means ut equals to 0 is simplified. X of t equals to what? This is the summary. X of t equals to phi t into x of 0. And what is phi xt? Xt equals to x1 t, x2 t, x3 t dot 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 xn t. And phi t equals to phi 1 1 t, phi 1 2 t, phi 1 3 t, phi 1 n t. And phi 2 1 t, phi 2 2 t, phi 2 n t. And last column row phi n 1 t, phi n 2 t, phi n n t. This is the n cross n dimension, and this is x1 2, x1 dot 0, x2 0, x3 0 dot 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 xn 0. So that is the term phi of ij t is the response of the ith state variable due to unity initial condition on the jth state variable when there are 0 initial condition on all the order of systems. So thank you.